So, we will demonstrate now the Michelson interferometer experiment. So, this is the experimental setup. It looks very simple, but it is very sensitive experiment. If I touch the table, then it will get disturbed. So, in this setup, as I showed you in theory class, that there is a source, laser source we will use. So, light is coming from this laser source, generally it is very this source is basically is almost point source, its rays are almost parallel. Okay. To make it extended, because for this experiment we need extended source. This is the convex lens. The convex lens we put here. So, its distance is almost 35 centimeter, although this focal length is 20 centimeter, focal length is 20 centimeters. Okay. So, if we put at 20, so you will get basically you will get a point. Okay. So, either so we have to keep, because otherwise real source if it is less than f, then you will not get real image. So, to get the real image, so we have kept this distance greater than focal length. Okay. So, then basically after focusing it will again diverge. So, we will get extended source. Okay. So, this as if here it is working as a extended source. Now, this light from this extended source, where it will fall? It will fall on the beam splitter, okay, or we are telling this half silver glass plate. So, this is the half silver glass plate. It is set at 45 degree, it is set at 45 degree with this incident laser light. Okay. So, if it is 45, so one will be reflected along this direction at 90 degree, and another one will transmit. That is what I showed in figure, right. One will just transmit and go towards the mirror M1, and another will reflect and go towards the mirror 2. So, here which one is mirror 1 and mirror 2? Which one is mirror 1 and mirror 2? So, this is the reflected from this surface here. So, this is we are telling mirror 2, and this is light is going directly here, this is a mirror. Okay. So, this is mirror 1, where light is going directly. So, that is the mirror 1, and this one is mirror 2, and this is the beam splitter or glass plate, where this reflection is occurring as well as transmission is occurring. Okay. So, now this again after coming to mirror 2, it will reflect back and go this in this direction, and from mirror 1. So, it is reflected from mirror 1 and come, and then it is reflected from this glass plate and go this way. So, these two reflected or whatever these two rays is coming from the mirror 1 and mirror 2. So, they will interfere and we will get interference pattern, okay, on the screen. So, here we have put this white skin, here we have put the white skin, and on white skin you can see the fringe, concentric circle fringe. Okay. So, the center one is bright one, and it's it can be bright, it can be dark, it can be bright, it can be dark. Okay. So, as I told, this order of the central one is the maximum, Now, if I change the distance of the one of the mirror by d, right, and then we will see when I am changing the distance of the mirror, there will be appearing or collapsing of the fringe at the center or from the center. Okay. So, that we have to count. So, this is the micrometer, it is like screw gauge. Okay. So, this micrometer, so initial reading we have to take, initial reading is here. I can see this initial reading, this circular scale, that linear scale reading. I can see this 5.5, it's a 5.5 millimeter, and this circular scale reading, this it's almost is 0, almost it is 0. Okay. So, least count we have to find out. So, so there are 50 division. So, if I rotate twice, so it shifted in linear scale, is shifted by 1 millimeter. So, least count of this micrometer is 0.01 millimeter or 0.001 centimeter. Okay. So, that things you have to note down, okay, in your yes. So, least count of the micrometer basically one linear scale, that is 0.1 centimeter for movement of the rotation of the, that is 100 division twice. Okay. So, least count will be 0.001 centimeter, that you have to note down. Okay. Now, I will note down this main scale reading, what I told, that is 5.5. So, better I will write this one 0.01 millimeter. Okay. So, this I can write in millimeter, main scale reading it is a millimeter. So, circular scale is a 0. Okay. So, total 5.5. Okay. That the initial. Now, I will change the distance of the mirror and take the final reading. So, when I will change, so what I will see? I will see this either appearing or collapsing the fringes at the center. So, it depends on both way, I will show you. So, now basically if I rotate in this direction, what you will see? So, I have done first. So, it is collapsing and appearing like this. Okay. So, I am changing, it is one, earlier one was there. So, 2, 3, it is gone more basically 4, 5, 6. So, going out it's a appearing. Okay. So, 7, 8, 9, 10, I think we generally take 20. So, I am changing. Okay. And I have to count that one, So, I am not counting, but one has to count, Okay. So, then it is a 20. Okay. Now, I have to take reading. So, whatever the reading from here you can take, but I am not taking because I have not counted properly. Okay. So, that reading you have to note down, in this. So, your final reading you should note down. So, this. Okay. So, this whatever the difference of these two you will get, right, difference of this you will get, and here as I told, this reading actually it is a the shifting of this, so the lever action here you can see I am changing here. So, lever action, due to this lever action, so it is shifting. So, this 1:10, okay. So, if this change by 10, so it is a shifting by 1. So, that is whatever reading we will get, so divide by 10. So, that will be the change of the distance of the mirror. So, you will get the D. So, when you will get the D and M you have counted, say 20 or 25. So, you can calculate lambda. Okay. So, you do this experiment 2, 3, 4 times. Okay. I will rotate it other way, then you will have feelings that this it is collapsing, you know. I will rotate it now, you see earlier it was appearing, now collapsing. Okay. Means collapsing means the order of the central fins is increasing, okay, is increasing. That means I am increasing the distance, I am increasing the distance between two mirrors. So, you see, so collapsing, okay. So, if I start from here, collapsing 1, collapsing 2, collapsing 3, collapsing 4, collapsing 5, collapsing 6, collapsing 7, collapsing 8. Okay. So, initial reading and then you have to take final reading. So, you will get the D value as well as M value, okay, and calculate lambda. Now, this so I have not shown you how to adjust it. It is very sensitive, okay. So, before starting this recording we have set it and very sensitive, you know. So, if I change the, you see, angle of this this glass plate, then you see this how sensitive it is, it is changing, just see it changing, okay. I am changing, rotating, you know. So, I am rotating, you see, I am rotating because slowly I have to do, otherwise I cannot come back again. Yes, yes, you see it is changing because of change of angle. So, we try to keep it when it is very distinct. So, that we take as a 45, angle is 45, okay, angle is 45. So, this is very sensitive with the change of the angle of the, yeah. So, angle of the glass plate, okay. So, I am getting, you see, 0 is shifted that side. So, we are trying to adjust 45 when we will get the symmetrically this one, okay. So, this is the position we keep, this approximately 45 degree. Now, this it change of the, it's the tilting of the, you see this two mirror has to be completely vertical, okay. If I change the tilt of the mirror, one mirror, so here there are option. So, you see this how sensitive it is, I am just changing the tilting, you know. So, it's tilting, it's okay. Okay. So, it is going 0, this central order is going out. You see, I lost, okay. It's so sensitive, again appear. So, very slowly I have to change, yeah, I got back, okay. So, other one is there. So, if I rotate this one also same way, it's you see, it's a, so this one is changing this way, other one is changing this way, okay, the tilt angle. So, it gone, okay. So, I have to come back. So, other way, it has gone other way, yeah, I have to come back, you see, it is so sensitive. Yes. Okay. So, this way uh, we have to adjust the tilting, we have to adjust the tilting of this mirror. So, when we will get, it is not very perfect fringe we have got, that is because it is the adjustment is not so fine here. So, it is really difficult to get more fringe, only we are getting few, still it is not, yes, it is shifted, you know. Okay. So, this tilting, and then we are changing the distance. Okay. So, effect you are seeing, Okay. So, setting this experiment is, handling this experiment is quite it is not difficult, but one needs skill to do that, and do the measurement, just taking reading is very easy. Okay. So, now what we will do? So, here you are seeing this, the here you are seeing that this is one mirror and this is another mirror, right. So, this light is falling here. So, this is one arm and this is another arm. Okay. So, if I put biprism in this arm, okay, if I put biprism in this arm, so here this optical path will be introduced in this arm, but this arm will remain same. Okay. So, now I will put biprism in one of this arm, in this arm. So, let me put and then start again. For biprism we will just do the experiment. Let me just first put the biprism. Okay. So, now I have inserted the biprism in one arm of the Michelson interferometer. So, this is the biprism, I can show you, I have the another piece. So, this basically we have inserted, this you can see there is a in middle. So, there is a line. So, that is the basically edge of this biprism. Okay. So, this biprism we have inserted in one of them. So, this is one mirror, this is another mirror. So, light is coming from this glass plate. So, in this direction. Okay. So, in this arm I have put this biprism. Okay. And this biprism is on a translational stage. This translational stage, it has linear scale as well as vernier scale. So, vernier scale have this 50 division, and linear scale it has smallest division is 0.5 millimeter. Okay. So, so basically you have to note down the list count, for so this is the table, determination of the base angle of the biprism. So, wavelength of the laser here, this whatever in earlier experiment you have found, that you can take, or standard value of this laser. I think exactly I do not know this, what is the, so it is written here 632.8 nanometer, 632.8 nanometer. Okay. So, refractive index of this material. So, from manual one has to note down which the material refractive index of the material. Now, list count, it is the, I found that, or this, in this case better, it is the vernier constant, list count is a vernier constant, it is a 0.5 divided by this is the millimeter. Okay, smallest division of the linear scale divided by total vernier division is 50. So, this is basically 0.01 millimeter or 0.001 centimeter. Okay. So, now So, earlier what we have done, so we are changing the distance d between the mirror, okay, one mirror we are translating. In this case, we will change, we will translate the biprism in and out in one arm. So, and then we will count the basically number of fins collapsed or appeared. Okay. So, that reading we have to take. So, here, so here this the, as I told, this list count of this one, this I think this we can show this scale. So, this is the vernier scale, this is the vernier scale and this is the linear scale. So, 50 divisions on vernier, and here the smallest division is 0.5 millimeter. Now, you see if I rotate this one, so before, so this is the now you see at this position, this is the fringe, this is the fringe. So, there is the order of the center fringe, we do not know what is the order, say it is M1. Okay. Now, I am changing the I am just translating this biprism either in or out. That means the light will pass through the different thickness. So, this reading I have to, I am not noting down. So, this reading I have to note down, it is approximately 1.95 centimeter, and vernier one has to find out, but anyway vernier is about 30. Okay. So, that is you should note down this initial position of the translational stage. What I told 1.595 or 19.5 millimeter, 19.5 millimeter. Okay. Circular is vernier, that is 30 into vernier constant 0.01. So, total you write. Now, I will count the number of fringe collapse or appeared when I am translating, and after that final position I have to take reading. Okay. So, for that let us move. So, you see now you see this fringe. Okay. Now, I am moving, you see if I go this way, so I have to count. Okay. So it is one has to be very careful. It is I could not do properly. Yes, I can do now. Okay. Anyway, now again if I start from here, I have to take reading. Okay. So, earlier whatever reading I have noted down, so they are disturbed. So, at present again I have to take. So, I am not noting down. So, just example I gave you. Now, I have to very carefully rotate. So, this one collapsing, you see, 2, 3, 4, 5, 6. Okay. So, it is the order is increasing of the central fringe. Okay. So, now it is M plus 6 kind, M1 plus 6. So, M1, that if it is M2, so M1 minus M2 will be 6. Okay. So, for this translational motion, if we take this final reading, so for 6, this number of orders collapsing, that is 6. Okay. For that reading you will get, but this reading will be very small. So, we take more, just do it and count, do it and count, do it and count. Okay. And say after 20 you take reading. So, this reading, difference of these two reading will give you L value, and here there is no factor because this is the normal translational stage. Okay. So, say so for 20, okay, it is collapsing. So, for that after that what is the reading one has to take, and then this one. So, you will get this minus this, you will get L, you will get T, then you will get phi. Okay. So, now you do more 3-4 experiment. Okay. So, other way I will rotate other way, then you see this appearing still collapsing, I am going in same direction. So, you have to take reading. Okay. When you are starting, when you are satisfied, take reading initial, and then I am going other way, you see now appearing, okay, as if from center one order is going out, so decreasing, decreasing. Okay. So, count 1, 2, 3, 4, 5, 6, 7. So, continue up to 20, 25, 30, and again you initial reading, final reading, okay, and then calculate the phi. So, few times, few observation you should do, few observation you should do, and take the average of them, you will get phi. And least count of this translation stage, and earlier. So, this for micrometer also so you can calculate the error, as I mentioned, you can calculate also error. Okay. So, this very sensitive experiment, but is very nice experiment, and very accurately one can get the result, wavelength as well as uh, this angle of the biprism, okay, base angle. Okay. So, here we are telling base angle one can calculate. So, if base angle is supplied, so in this formula actually what happens, in this formula you see you have lambda, you have mu, and you have yes, okay, and also this you have lambda, mu, and phi. Okay. So, if 2 is known, then third one you can calculate. So, in this method basically mu also one can find out if this angle is given, base angle is given, then mu can calculate, or mu is supplied. So, one can calculate base angle. Okay. So, experiment is same, but just calculation will be different. So, I think I demonstrated Michelson interferometers, how to measure the wavelength and how to measure the angle of the biprism or refractive index of the biprism, okay, and how these feelings also we got, how these fringe are collapsing or appearing depending on the distance of the mirrors or thickness of the biprism, thickness of anything, so if you change vary the thickness, so biprism is a nice, there is a variation of thickness, just if you translate you can get the variation of thickness, change of the optical path. Okay. So, with that how fringe are appearing and collapsing, that feelings we are getting, that also nicely we could see. Okay. So, I will stop here. Thank you for your attention.